So this will be a presentation about implementation of prototype-based inheritance in Titanium. My name is Skugor. I live in Split, Croatia, and I work for Tipsy and Tumbler. So let me first talk a little bit about the problem. So object-oriented programming in Titanium. So you know that Titanium provides JavaScript environment, and in JavaScript there is a prototype-based inheritance that's available natively, but Titanium objects cannot be used as prototype objects, and because of that there is no object-oriented programming in Titanium. Let me first talk a little about when object-oriented programming has a sense. Basically, on a smaller projects, you won't find so much benefits in using object-oriented programming as much as you would find in larger projects. And in last company in which I worked, I was working on a large project, and that project was made just for Android, and it was in-house application for data collection. And I had to make a lot of forms, and those forms were very similar. So I wanted to develop something that will enable me to make all that stuff easier. So the problem is not only inheritance of Titanium objects, and when I mean Titanium objects, I mean Titanium UI objects. The problem is extending. So it's a bad practice to add new properties or new methods to Titanium proxy objects, because you may know that in the history you couldn't add methods that began with set or get, because things that just didn't work. The other problem is instance of operator. So currently in Titanium, you cannot know what's the object's type. So instance of operator doesn't work on Titanium objects. Instead, you have to use the toString method, but that method is not standardized, and it produces different string on different platforms. So you have to extract parts of that string to know the object type. CommonJS TIAPI. So Titanium introduced CommonJS in 1.8 version, but Titanium API is still not written in that way. So you cannot just require UI button and store it to local variable in your CommonJS module. Instead, you have to use ti.ui.create button all the time. So this is maybe not a big problem, but I wanted to have something that will suit more to CommonJS approach. Non-uniform TIAPI. So what do I mean by this? So for example, table view has an add method, but that method doesn't do anything. Instead, you have to use a setData method. This is not a problem for experienced developers, but if you are a new developer, you will try to use basic view, and you will use add method to add other components, and then you will try to use table view, and you will see that add method exists and it's documented, but you will see that actually it doesn't do anything. There are also other examples. For example, a tab group. It has add method, but you have to use the add tab, and the scrollable view has also add method, but you have to use add view. And I found that Titanium has, let's say, a lack of functionality or unreliable functionality. For example, every new SDK version solves some issues, but it introduces new issues. So things are getting better, but at the time that I developed I was developing this application, and especially for Android, things were very buggy. So I had to find a way how to solve this SDK problem. I also missed some functionality. So for example, you cannot traverse through all UI hierarchy. So for example, if you have a window that contains a view and that view contains a button, there is no way to go from that view to its parent element or its child elements. Currently, you can use children property, but through history, this was very unreliable. So first, there was also parent property and children property, but at once they decided to remove them, and after they added only children property, and some UI elements had that children property, the other didn't, so that there was no reliable way to use that. Code reusage across platforms. You all know that you can write code for particular platforms, but the problem is for example, if you want to have some common functionality for both platforms, but you want to, let's say, that some component exists on iOS and it doesn't exist on Android, you have to replace them, but that both components can have some common functionality. And I didn't find any technique that will enable code reusage across platforms. So my idea was to build native JavaScript wrappers. So basically, this was common practice in Titanium community. Basically, we just use a native JavaScript object to store a reference to Titanium object. And when you want to, let's say, add properties or methods, you just use this native JavaScript object. And when you want to do something with the Titanium object, you just get that object through this property. And we usually call this property element, but that approach has a problem, and that is inheritance. So you cannot just use this native object as a prototype object, because when you put it as a prototype of some function, when you create a new object, you will create new empty object, and that object will reference this element through its prototype chain. And now when you create another one, you will get another empty object, and you will reference the same element through this prototype. So you won't have mapping one-to-one from a native JavaScript object to Titanium object. And I've solved this by using a function, and I will show you how. The idea is very simple. So at the end of this function, I will just return a reference to this Titanium object. But before that, I will check if that object exists. If it doesn't exist, I will create it. And the important part is here is to use this get properties function. This function copies properties from this object, and not only this object, but all objects that are in its prototype chain. Because otherwise, Titanium ignores all the properties that are defined in prototype chain. And this is a basic demonstration how to use this. So if for example, if I want to create on method that basically adds new event listener, I will use this dot get TI element, and I will at this time titanium object will be created, and then I will just add event listener. And it is important to use object-defined properties, because titanium has one bug, and if you don't use this this object-defined properties, you will end up in an infinite loop. I'm not sure what happens there, but it happens for some reason. And now I can just extend this basic wrapper. Then TI is just framework name, and extend function is basically the same function that every DOM-based JavaScript framework uses. So it's nothing spectacular. And I can just define some properties. Define properties is just a shortcut to define properties. So I don't have to use this enumerable, writable, and configurable. And the demo is here. So basically this huge black view is this base class, or base object, and this is extended view. So now if I click on this, we will see that instance of operator works. So this small object, so small white view, is an instance of this basic wrapper. So this is a basic theoretical approach, and if you are using wrappers, and if you are using this element property, you can just replace it with this technique. But my implementation is far more complex. So this is how it looks. There is one base wrapper element. This element contains all common functionality like get properties, set properties, add event listener, get parent element, and things like that. And there are three basic wrapper types. First is control. Control is base wrapper for all components that cannot contain other components. So for example, button, a label, text field. So if titanium has an add method on a button, for example, so that this might work somehow on iOS, but on Android it won't work. So I wanted to just remove functionality that doesn't exist on the that elements. There is a container type. Container type is a basic wrapper for all components that can contain other components. For example, view, scroll view, table view, and so on. So you can add children, you can get children, you can get particular children, you can loop through all children. And the last type is context type. Context type extends container, so it can contain other elements, but the difference is that context type creates new visual surface on the screen. So basically these are window, tab, and tab group. And now a few demos. Just a second. So for example, if I want to get particular child, you will get that this is object then button, and the object title is get child. I can loop through all children. For example, now you will get all four buttons here. And I can get parent element. So parent element of this button is a window. And for example, if I want to add a window to a view, that's basically irregular action. So you cannot add a window to a view. And in Titanium, you will get a strange Java and Objective-C exception, and it will be hard to know what that exception means if you are not iOS and Android developer like I am. I came from web development, so it takes a lot of experience to understand all these exceptions, and I wanted to have a JavaScript exception because the advantage is that you can catch these exceptions. So if some exception occurs during the runtime, you can just put your code into a try-catch block, and it will be catched. So, and I get error message that tells you what you did. So you cannot add window to view. And composite component. This is, I wanted to have some kind of functionality that will enable me to use composite components. And for example, this whole screen is one component, and it contains 3 views. So red view, green view, and blue view. And now, for example, if I want to replace this green view, I can just easily do that. This is a code that this is a code of this big component. So I just create top, middle, and bottom view and set their colors. And now I can just extend that component, and I can just override create middle method. And in there I just create scrollable view instead of basic view. So you can now see that this is not scrollable. And this is new component that extends that one. Now you can see that this middle component is replaced. And since I was working with a lot of forms, I wanted to create functionality that will enable me to get all the values from form automatically. Because currently in Titanium, you cannot do that. For example, if you have these 2 text fields, and on this submit button, you have to store references to these 2 text fields. And now, this is not a problem if you have a small number of input elements, but for example, if you have 1,000 elements, then that is a problem. Even more, if your client changes a request and he says, okay, now remove 100 and add another 100 of other components, then you will be in a problem because you will have to modify a lot of your code. So I will just show you how this works. Basically, there is no code that, for example, this is on submit function. So I just call this get value function. There is no references to any of these text fields. And I will get my username and first name. So if now I update this form, I add my last name, and click submit again, I automatically get my last name. So this was a huge time saver for me. And you may not notice, but I use this notation. So instead of just using indexes, I use string names. Why I do this? Because I think it's easier to remember component's name than index. You will remember form view, but you may forget about 5 or 10 or 15. So this way I could easily get this component in the future. And also, if your components change their position, you wouldn't have to update these indexes all in your code. So, weaknesses. Well, first weakness is speed. When I created this, I created it for only one particular Android device that was fast, and this worked fast on that device. But there are many Android devices that aren't so fast. The difference between a native Titanium development and this approach is not a huge difference, but it's a noticeable difference. So maybe it's not yet ready for general purpose use, but I will show you how I plan to solve this problem. Size, well, maybe. The total size of this framework is 250 kilobytes, unminified version. And now if you take into account that your average application will have about 15 megabytes, 250 kilobytes is not a large number. And you can try this framework. It's available on GitHub. And you can tell me what you think about it and what you think that could be better. And future work. This work lasted for some time, and I changed some concepts in it. And some components are, let's say, older components that needs to be refactored. And I need to implement platform-specific components. I mostly used it on Android and not on iOS, so need to do that. Improve quality to alpha release. It's still in experimental phase, and I need to test it and benchmark it and find the ways how to improve it even more. Optimize. Add unit tests. At the time when I started to work on this, there was no testing framework for Titanium, so I just skipped that. But now, let's say some people use some testing frameworks. I'm not sure how good are they, but hopefully I will try it. Write some documentation and integrate Carbon framework for speed. Basically, I think that the integration of this framework will bring huge speed improvement, because I had to add a lot of overhead to this framework to make this work. And because of that, framework is not in an optimal state. And I thought to make some native modules to improve speed, but I'm not iOS or Android developer. I came from web development, so I firstly need to learn those skills, but fortunately this framework came out that does exactly what I need. So, but I only need to find free time to do all this, because I don't have much free time, and if I do have it, I spend it on some other things. And related work, well, there is not much work. There are not much frameworks for Titanium framework, and especially there are not frameworks that enable object-oriented programming. There was one framework, but it actually emulated classes, so I wasn't very satisfied with it. I'm not a fan of classes in JavaScript. So there is also Alloy has some, let's say, inheritance functionality, but as far as I know, it just copies properties from one object to another. So you can forget about instance of operator and things like that. And that's it for now. If you have questions, you can ask.
Could you explain to everyone what the common framework is and how it's different from another? I don't think everyone's familiar with the common framework. It would be good if you could explain how it works and what it does and how it's
Okay. To be honest, I didn't explore it much, but how it works, it actually, you can send a JSON string to Carbon, and Carbon will take care of UI creation. And why is that good? Because you won't have to cross the bridge from JavaScript to native Titanium so many times. So for example, if you are creating some complex UI, you would have to cross this bridge many times. And because of that, you will have some performance drop. But with Carbon, you will just have this one cross of this bridge, so from JavaScript to Titanium. I didn't yet try it. I'm not sure how fast it works, but it seems that it works very, very fast, and this difference is more noticeable on more complex UIs. Any more questions? Oh, well, it actually doesn't use many memory because every function is defined on the prototype. So, for example, Alloy uses a lot inner functions, and every time you create new controller, you will get new function. And JavaScript engines cannot optimize this internal functions a lot. They can optimize this approach. So if you have watched some advices about how to optimize your JavaScript code, everyone suggests that you use a prototype-based approach. So if you define your functions on a prototype object and use function constructor to create new objects, then JavaScript engines will optimize that code. So in that respect, I didn't yet test this, but in theory it should actually use less memory than some other approaches. What I didn't hear. Yeah, I don't say that this is a perfect solution. It's not yet optimized, so this is still, let's say, an experiment. Because I wanted to create, let's say, more elegant way to use Titanium API, and I wanted to have some other functionality that Titanium doesn't have. I wanted to use object-oriented programming. So in domain in which I used this, it was a great tool, but maybe it's not suitable for any use case. But maybe some future work will make this also other use cases possible. So for example, I created one wrapper for every titanium component. So this can be optimized in a way that I don't include all components, but only one that you actually use. And basically, there are only three basic types, as you know. So this source code is, let's say, relatively small. So you can just, let's say, I can make some more optimal solution, so you can use just components that you actually use in your code. Any more questions?
This is unrelated, but you know quite a lot about TIShadow. For a lot of people here, you have TIShadow code. Can you explain what that is and how they can use it? Because I mean, that's quite
Well, yeah. First of all, you should start using TIShadow if you already are not using it. What TIShadow actually does, and with TIShadow, you don't have to compile your application every time. And for example, on Android, compilation takes a lot of time. And now, when you are building your UI, for example, you miss some pixel here and you want to correct it, to be pixel perfect, you have to compile it and compile it and compile it, and that takes a lot of time. With the TIShadow, you actually don't compile it. How TIShadow works? So that TIShadow consists of two parts. First part is TIShadow server, and the other is the TIShadow application. And basically, you don't compile your application, you just send your source code over this server to your application, and then that code is evaluated. So there is no this compile step, and this works much faster. So you actually see the changes in a split of a second instead of waiting half a minute or more. You can check TIShadow on a GitHub page and try it, and you will be impressed with it. Shadow.